All right, in this video, let's talk about problems 5 and 6 on your linear programming group work. These ones were slightly different than the more traditional problems that followed the same pattern over and over again for our linear programming work, so I just wanted to run through them with you one more time. All right, so in number 5, it says a company is planning to buy new carts to store their merchandise. The owner believes they need at least 2 standard carts. That's going to be important. They need at least 2 standard carts and at least 4 deluxe carts. The company can afford to purchase a maximum of 15 carts at this time. Okay? So that means 15 carts total between standard and between deluxe, total of 15 carts. Standard carts can hold 100 pounds of merchandise and deluxe carts can hold 250 pounds of merchandise. Okay? So the question is, we're going to write a system of inequalities to determine how many carts, standard carts and deluxe carts, do we need to buy to maximize the amount of merchandise that can be stored. Well, in this problem, there are not carts telling you what to do. So the first thing you need to start with is figuring out what are your variables. What's going to be X? What's going to be Y? And when you do this problem, you always look to when they talk about maximizing something in order to figure out your variables. Well, here we are maximizing the amount of merchandise by determining how many standard carts and how many deluxe carts. So I need to have variables for standard and deluxe. So let's make X the number of standard carts and Y the number of deluxe carts that this company can buy. Okay. Now, as usual, let's start by setting up a table here. The table, you don't have to do it, but it helps you stay organized. So we have the topic of our equation, our X variable, Y variable, and the total amount we're given. Now, when I look at the second sentence here, it says the owner believes you need at least 2 standard carts. That is a stand-alone equation. You are going to take the number of standard carts, and we just need that to be greater than or equal to 2. Usually we use greater than or equal to 0, but here they're very specific that you need at least 2 standard carts to buy. They also need at least 4 deluxe carts. Okay? Those do not go together in one equation. Those are 2 separate constraints on this situation, the number of deluxe and the number of standard carts. Now, the next sentence gives you something that's going to go in our table. The company is affording to buy a maximum of 15 carts, and 15 carts in total. That's the topic of that is how the number of carts they're going to buy. When you see a total value, so here a total value of 15, that's going to tell you that that's something that needs to go into your equation. Right? We can send or buy at most 15 carts, so we need that to be less than or equal to symbol. And again, this is a total number of carts between the standard and the deluxe. All the standard plus all the deluxe carts they buy have to be less than or equal to 15. They can't go over it. Right? We cannot make any other coefficients on those variables. Okay. So now we get to the stuff that's underlined in purple. And some people were getting confused by this in class, so let's make sure we understand here. When I look at what's in yellow, right, I highlighted that we are trying to maximize the amount of merchandise that can be stored. So here we're not trying to find the profit, we're trying to maximize the amount of merchandise. So I'm going to call that M. The amount of merchandise that can be stored is a function of the number of standard carts and deluxe carts that you buy. Now, what this tells us up above is that the standard cart can hold 100 pounds of merchandise. All right, that's going to help us figure out what the maximum amount of merchandise is. So we're going to do 100x, saying that a standard cart can hold 100 pounds of merchandise, plus deluxe cart can hold up to 250 pounds. So we'll do plus 250y. That is your maximizing function that we're going to come back to in a little bit once we graph our line. But notice, we have now used every single number in this situation, which means that you are ready to graph your lines. Okay, the first line is pretty simple. We'll do x is greater than or equal to 2. Just like we talked about in class today, that is a vertical line at x equals 2. So we can go ahead and graph that one right here. We also have a line at y is greater than or equal to 4. That's a horizontal line at y equals 4. Now that third equation for the number of carts, that needs to be solved for y. So I'm going to bring it down underneath here and solve this equation for y, which is actually pretty simple here because all you have to do is subtract x from both sides. The equation, the inequality or constraint you're going to graph is y is less than or equal to 15 minus x. That means you have a y-intercept of 15, and you're going down one, right one. Pay attention to where you cross the other constraints. This problem only has 3 constraints, 3 equations that we have to graph. So we only have 3 lines here. Okay, so once we graph these, since I had 3 lines to graph, you're going to have a 3-sided polygon, which is a triangle. And you can shade in here the feasible region, which is bound by all 3 of those lines. Now the next step, once you graph those 3 lines, is to notice the points that are the corners of the feasible region. I'm going to write them right under the maximizing function here. All right? This bottom left one, we're going to maximize the point 2, 4. Okay, I'll just write them like this to save a little bit of room. I'm going to maximize the point on the right here, 11, 4. And finally, I'm going to maximize 215. Those are a combination of deluxe and standard carts. All right, so what I'm going to do is I'm now going to take, I'm trying to move this over a little. I'm going to take each of those ordered pairs and put them into our maximizing function. So I'm going to have 100 times 2 plus 250 times 4. And that's going to tell me the maximum amount of merchandise I can store with 2 standard carts and 4 deluxe carts is 1,200 pounds. Okay? I'm going to do the same thing with the next 2 functions. All right, 100 times 11 plus 250 times 4 gives you a maximum of 2,100 pounds that can be stored. Okay, last one here. All right, so as I look at these, it looks like the maximum amount of merchandise that can be stored is 3,450 pounds. So we have a maximum storage of 450 pounds when the company buys 2 standard carts and 15 deluxe carts. Right, so I wanted to go through that problem because it didn't fit the typical mold of what we had been doing, and it had a couple different inequalities. So I'll scroll back down here if you need to see the work. All right, I'm going to do number 6 next. So if you need to see this problem again, pause the video and go back over it. All right, number 6 is also a little bit different, but I think you guys all have a little bit better time with it than number 5. All right, number 6 says your school is planning to make hats and mittens to sell at a winter festival. The sewing class is divided into 2 groups. One group makes hats and the other group makes mittens. The sewing teachers are willing to help out as well. considering the number of people available to help and time constraints due to classes, you can't sew all day long, only 150 hats and 120 pairs of mittens can be made each week. Now, the sewing classes do get enough material every Monday to make a total of 200 items per week. Because this material is donated, each hat has a profit of $2, and each pair of mittens makes a profit of $5. Now, this last sentence helps us figure out where to start. In order to make the most money, how many of each item should be sold each week? That helps us find our variables. Remember, we start by figuring out what is X and what is Y. Well, what are we making? We're trying to make a profit on hats and mittens. So let's let X be hats, and let's let Y be the number of mittens that are being sewn. Now, once we start that, let's set up a table again. Okay? So we have our regular table. We have a topic of our equation, our X value, our Y value, and the total. Now here, it might actually be easy to let's do our profit function before we go back and figure out the other equations. Because it was very clear here. We have each hat that's sold makes a profit of $2. So our profit function for hats and mittens is going to be $2 per hat and $5 for each mitten that is sewn and sold. Now, what you need to do is, let's go back and figure out what our equations are about. So let's start with the stuff that's underlined in pink. Okay? Those have to do with the number of hats and mittens that are made individually each week. So the number made will be one of our topics. Okay, let's see, that's squeezed in there. Okay. All right, now here's where you need to be careful. This first one says only 150 hats and 120 pairs of mittens can be made each week. Those are independent of each other. The hats, it doesn't matter how many mittens you make, you cannot make more than 150 hats. So I'm going to put that in here as writing the equation X is greater than or equal to 150. I cannot make more, X is less than or equal to 150. I can't go over 150 for the number of hats. Same thing for Y. The mittens is totally separate from the number of hats that's being told. You cannot make more than 120 pairs of mittens. Now, the reason that seems kind of confusing is because right down below it says you can make a total of 200 items per week. Well, that's going to be an actual equation together. This means a total between hats and mittens together of 200 items. So all the hats plus all the mittens cannot be more than 200. You just don't have a total up here because we didn't write a whole equation with X and Y. Okay. So now I've used every number actually. I've used the 150, the 120, and the 200. So those are going to be 3 lines that are on our graph. Now we need to be careful because let's think about this. I can't make more than 150 mittens, but I also have to remember that I also have the constraint that the number of mittens has to be greater than or equal to 0. I can't make less than a negative number of mittens, or hats, Same thing with mittens. The number of mittens also has to be greater than or equal to 0. So really you have 1, 2, 3, 4, 5 equations that you need to graph on your grid. Well, let's start with the really easy ones. X is less than or equal to 150. Let's do that one. That's going to be a vertical line at 150. So go over here, say, okay, my x's can't go past there, but then remember I also had a line at x equals 0 on your axis. Same kind of thing here for y. Y is bigger than 0. I can't make negative mittens, but I also have to be under 120 mittens. So out of 4 of my lines, I only have this one in green left to do. Let's solve it for y. To get y by itself, you need to subtract x. You're going to have that y is less than or equal to 200 minus x. So if I go back up to my graph here, I'm going to start at 200 and have a slope of down 1, right 1. Make sure you're really careful so that you see where these graphs intersect each other. All right. Now, since we graphed 5 lines, you should have a bounded pentagon that has 5 sides to it. That looks like it is down here. 1, 2, 3, 4, 5. This is your feasible region. It looks a little different shape than what we're used to, but that is the solution. So let's darken in your 5, vertices here. And let's make sure that after you grafted that you have the same vertices that I do. So I'll start here on the bottom left. I have 0, 0, so we're going to find the profit of making 0 hats and 0 mittens. The profit of, I'll go up this time, 0, 120, 0 hats and 120 mittens. The next one over here, top right, is 80, 120. So you want to find the profit of making 80 hats, 120 pairs of mittens. Then we have 150, 50. So the profit of 150 hats, 50 pairs of mittens. And finally, 150, 0. So what if you made 150 pairs of hats each week and no mittens? What is the profit? So I'm going to give you a couple minutes. I want you to pause the video. I want you to put each of these x's and y's into your profit function, which I'll highlight up here so you can see it. So for the first one, you would do 2 times 0 for x plus 5 times 0 for y gives you a profit of $0. That makes sense. If you make 0 hats and 0 pairs of mittens, you should make no money. All right, so pause the video. I want you to find the other maximums on this problem. All right, let's finish up here. So once I put all those ordered pairs into my profit function, it appears that $760 is the maximum. So the way you would write your answer is to say that your school would make a maximum profit of $760 if they sell 80 hats and 120 pairs of mittens. I hope that those videos on number 5 and 6 help you out. If you need help on any of the other problems in the group work packet, you can either email your teacher, come in for help, or check the key that is posted on Canvas. All of the work is there.